number of numbers do we want to see go over our questions about?
2, 4, 5.
I need you guys to focus on thinking just 2 numbers. I think the ones that you the most, I know 4 and 5. If you weren't a 4 or a 5, can you put your number back up? Or if you had something other than a 4 or 5, just so I can see the other ones.
No, there's a 2. No, there's 3.
Majority is 2, so we'll do 2, 4, and 5.
Yeah.
So the equation of number 1 is a vertical line. So if it's a vertical line, it should be an x equals. Where does this cross the x-axis? 1. If you're not answering my question, you should not be talking. X equals 1 is your answer to number 2. On to number 4. Write the slope-intercept formula of the equation of the line through the given point and slope. So this is what we were just doing on the test. We have our x1, y1, and our m. So this would be y minus 0 equals 1/3 times x minus 5. This is just going to become y, and we can distribute the 1/3. Y equals 1/3 x minus 5/3. Questions on that one? And then for the last one, how many solutions does this have? Look at the coefficients. Does this have 1, infinitely many, or none? 1. They have different coefficients, so 1 solution. You did not need to solve this. If you did, that's fine, but you didn't need to. Because you should be able to tell just by looking at that. Okay. Look at your course calendar. Can you wait till after we talk about this? Okay, so you'll notice that this goes into the new year. Granted, there are no snow days between that because then it would change. But as of right now, this is your schedule. This is really 2 short units combined into 1. So we're going to go through the notes. Most of it will happen today. Any notes we don't get to, we'll finish next class. Then we'll do some activity that will help you practice what we're going to be talking about. And then you're going to take a quiz, because the activity will be practice review for the quiz. You'll see what we're talking about in a moment. Then the next class, we're going to go over the quiz. And you're going to do a summative activity. Not a test, but an activity project. And then the next class will start the next day. Next class. So then the 18th will be the next quiz after that. And then the 20th, I don't know if you guys know about this yet or not. If there are no snow days, that's supposed to be an even day anyway, but the schedule is being arranged so that you guys, I would see you during first block instead of your normal block, so it would be shortened. So that would be a short flex day. Take notice of when your Delta math assignments are due. There are 3 total. 2 due dates, the 15th and the 20th. So everything is due before you guys go on with your work. And then the tests we will do for that last part when we come back next year. Questions on any of that? Let me say this about the summative activity. If you are not here the day we do the summative activity, you are taking the test instead. If you retake the summative activity grade, you are taking a test instead. that in mind. Are there any questions, concerns? Anything we want to voice now before you start? You don't need your iPad right now, so go ahead and close it. If you have your laptop open, you can also go ahead and close it. Great. So let's start on these notes. As you've seen already, we're going to be talking about scatterplots, linear regression, line of best fit, all those things. Some of that should be familiar to you. Some of it will be new to you, especially how we do it on the calculator, how we do it on desmos. A or blank are used to determine whether or not two variables are related. That is scatterplots. Probably should have made more room for that one. A trend is when a change in one variable affects the other variable. Trends help us make sense of the world around us and help us make predictions. I'm going to let you guys try to figure out this one. A blank trend occurs if one variable increases when the other variable increases. Positive. This trend is much like a line with a positive slope. So when you think about positive trends, your x's are increasing as your y's are increasing. And then, what would this one be? A negative trend occurs if one variable decreases when the other increases. So if the x's are increasing and the y's are decreasing, that is a decreasing or a negative trend. Or if vice versa. This trend is much like a line with a negative slope. Then there's one other kind, so positive trend, negative trend, and does anyone know this one?
No correlation.
No correlation. Between, in this specific example, the number of newspapers sold and the temperature in the following example. You can't really see a positive or negative. Flip over to the back. Another term used to describe two data sets that have a connection or relationship is a this table might help. Not really a relationship. Just one word. Something that repeats in this. You ever take a stats class, they'll say correlation does not equal causation. That means they could be positively or negatively correlated, but that doesn't mean one causes the other. The correlation between two sets can be positive, negative, and it can be strong or weak. And then this kind of talks about those different things. Okay, so we'll go through some of these examples and then go on. Really, we're just going to talk about 1 through 6 and then kind of move on. Do we think this is positive, negative, or no correlation? Which one? No. It doesn't really look like one way or the other. What about number 2? Negative. Number 3? Positive. 4? 5? And 6. So those are the directions. Now I'm just gonna talk about the strong weak. Strong is when it's almost in a line, or like you see it in a line. So this would be strong, this would be strong, or stronger than the other ones. This one's not as strong, but it's not super weak either. So you could say strong, not as strong, you could say weak, either or. The way you really find that is, we'll see that when we do our linear regression, there's a specific value that will tell you if it's strong or weak. We're skipping 7 just because that's really just plotting the points, but you are welcome to go back and do that if you so choose. Same thing with 8. So this is you thinking about this in general. Would these increase together? Would one decrease while the other increases, or do they have nothing to do with each other? So the number of hours a person has driven and the number of miles driven, would those increase together? Would one decrease while one increases, or do they have no relationship to each other? Positive, negative, or no correlation?
Positive.
Positive. The number of siblings a student has and the grade they have in math class.
No correlation.
No correlation. They have nothing to do with each other. The age of a car and the value of a car.
Positive. Negative.
That one is actually negative. The older a car is, well, that depends. But like if I have a 2018, the value goes down every year. It depreciates. Is what that helps. But if you get like a 2023, then the value is higher. Okay. The number of weeks a CD has been out and the total sales. I would say positive if it's like a hot album, hot CD. Because the longer it's out, usually the more sales it is. Number of years a person went to school and their income.
Positive.
So there were different ones there. Why positive?
Because college.
Usually, so like if you go to college, or the more you go to school, the better income you might be. But that's not always the case, so I can see the no correlation. But for in general, we'll say positive.
What is the positive? Like, couldn't some of these be both negative and positive?
Maybe the CDs, because the longer, like, the number of weeks, if it's past a year, it's probably not going to have the same amount of sales it did at the beginning. The number of sales will start to go down eventually, but I don't think they're talking like that far down the line. So that could be negative if we thought about it further out. But which one is another one you think could be both?
Like, the number of years a person is school, like, or actually about like the age of a car and the value of a car. Like if the car's 3, the value could be high. Like we don't really know how, like what time we're talking about.
So that one is negative regardless because cars depreciate. They lose value over time. Unless it's like a antique. Then those are more valuable. So it depends on the scenario. The number of sounds downloaded on your iPod, I didn't make this, on your iPod, and the amount of memory available. Negative. The more songs you download, the less space you have. Yeah, okay, negative. I was about to contradict myself, sorry. The amount of time spent on your computer, instant messaging your friends, and the number of computers in your house. And the age of a house and the number of people living in a house. So you can really do this with anything. You could pick 2 things and see, do they correlate? Is there any sort of correlation to them? Do we have any questions about correlation in general? I just had to throw that in there because they added that from the county. So this is really what we're going to be quizzing and testing on. So let's go through this. We'll go through this part quickly because it is helpful information. If I wanted to find the value of y for each of these numbers, I could put -2 in for x and then find y. So y equals 3 times -2 minus 4. What would that give me? -10. And I can do that for all of these, so let's do that. Y equals 3 times -1 minus 4. -7. Y equals 3 times 0 minus 4. -4. Anyone start to see a pattern? Goes up by 3 each time, so that means this one should be, and this one is close. But doing this part will help us when we get to our tables. There are other ways we could have done this. We could have put this into Desmos or the calculator, put this in, found those values, a bunch of different ways. We're not going to do the second example. That part doesn't really matter. So the scatter plots and the correlation that we talked about, those all have specific data, but there's no like line to fit this data. Like, how could I use this data for in general? So that's what we're gonna try to figure out. There is a line that best fits this data. It may not touch all of the points, it may not go through all of the points, but I could use this line or this equation in general to figure out any amount of time or whatever. So in this example, we have number of hours for time spent studying for the test. This is not something specific to you guys, just data in general. You need to know which ones are the x's and which ones are the y's. X's are your independent, y's are your dependent. So if you're not sure, you can always ask, would time spent in hours depend on the grade, or would the grade depend on the time? So since grade depends on time, grade is y, time is x. Okay, so we're going to try this in the calculator first, and then I'm going to show you how to do it in Desmos. And then after I show you both ways, you'll really have a choice. You'll be telling me in the calculator, go ahead and reset it because everyone's been doing so many different things to it. Second plus 7, 1, 2. If you get lost at any step, all the steps that I'm saying are on your paper. So we're going to go into stat, and it should be on edit, put enter or hit enter. L1 is always going to be your x's, L2 is always going to be your y's. So you're going to put those numbers in. You can do this one of two ways. Either typing in the numbers and pressing enter, or typing in the number and then pressing the down arrow. Either one works. So take a second and fill out those numbers. Do you have these numbers already in your calculator? So if you don't have your calculator, you should probably go there. Once you have your numbers in there, we're going to go to the next part. So on your notes, it just says stuff about clearing the list and missing lists. We'll talk about some of that stuff here in a bit. Step 2, we're going to go into stat. Scroll to the right to calc or calculator. And then we've been dealing with a lot of y equals mx plus b stuff, so we're looking for the linear regression. There are 2 of them, but we need the one that looks more like our slope-intercept form. It's a instead of m, but it is the same thing. So stat, calculate number 4, or you can scroll down to number 4 and hit enter. And then yours should look something like this. Just make sure this says L1, this says L2. We don't need anything for the frequency list, but go down to store regression equation. And you're going to hit alpha trace. Trace is at the top by zoom and graph. You should get something that looks like this. And then you're going to hit enter 3 times. So right now this doesn't seem like much. The answer is also there at the bottom, just in case you missed that. We would, if it asked, write that down as the line of best fit, and then use that to do different data things with it. Now, I'm going to, you don't have to do this, but I'm going to show you what the graph would look like, just so you see what this is really doing. So those are the points we put in. This is the line we just found, and this is the line that best fits this data that I could use for any amount of time to find any grade, in theory. The goal for us is to find this line and use it to make predictions. So let's write this on the next page. I just have to go back into it because I don't have it. So on the line of best fit, you're going to write y equals, you don't need to put all of the decimals, but you should be putting at least 3. So 6.012. X. And then our B is 53.6158, so we're going to round that to 6.6. And I'm going to show you a couple different ways on how we can find this information. One will be to use the store function on your calculator. In a moment or a little later when you have time to practice, I'm going to give you a sheet that has all of these directions again. If we are predicting the grade for a student who studied for 0 hours, this would be our X or our Y. 0 hours. Was number of hours X or Y? X. So 0 would go into X. You could do this algebraically. Put 0 in, and you would get out this number. So that would be your answer. If you want to do it in the calculator, we're going to store 0. So 0, I just typed that in. STO, the button above on, and X, and hit enter. It'll look like nothing happened, but then we're going to go back and grab our equation. Alpha trace is where we stored it in Y1, so you can hit enter twice. And it basically takes 0, it puts it into your equation with all of the decimals, and it solves it for you. So 53 point, when we write our answers, at least 2 decimals, but when we write our equations, 3. The 6.2, 53.62. If it was something other than grade, we would put a label behind it, but it's just a grade, so you could put percentage, but it's not necessary. This only works if you, when we were in the stat calculate if you stored the equation. So if you didn't do that, this won't work. We're going to do the same thing for 6. So type in 6 STOX and hit enter. And then do it again and hit alpha trace. Some of you aren't practicing this in your calculator and you're going to be confused when you have to do it. So then that would be your answer for that part. 89.69. The last part, how many hours do you need to study to get greater than 100%? Are we looking for an X value or a Y value? X, because we have our Y value. So if you wanted to, you could put this in for Y. And solve for X like a normal problem. That would be one way to do it. That will always work. Same thing with putting these in for X, but if you put these in for X, you have to use all of your decimals if you're doing it by hand. So you can do it that way. I'm going to show you how to do it on a calculator. We're going to go into the table, the second graph. Again, this only works if you store the equation in your calculator. But we're looking for when our Y value is greater than 100. So we know at 8, it definitely is. But if we wanted to find something specific, like an actual decimal, we're going to change this so we see the in between. Hit second window. And then we're going to change the table start to 7. And change this to 0.5. To see somewhere in there, I know it changes. And then go back to the table, second graph. Now I see between 7.5 and 8 is where it's greater than 100. So if I wanted to find maybe the specific tenth, I would do it again. Second window. I'm going to change this to 7.5. Change this to 0.1. And then go back to the table, second graph. Okay. Now I can see specifically at 7.8 hours is greater than 100. And that would be my answer. You could keep doing that until you find the nearest 100,000, whatever you want, but 7.8 is fine. This one needs a label because we're looking for number of hours. The calculator has a lot of steps. With practice, you will get better at it. But I'm also going to show you how to do it in Desmos. For the summative activity, you will be able to use Desmos. So open up your iPad. Get an iPad if you didn't read the directions on the board when you came in. In Desmos, you're going to hit the plus, and you're going to make a table. In the table, you're going to put in all of your X and Y values. So on this page, you can put these in. The numbers are a little hard to read, so if you need to follow mine, that's fine. It's 6, and then 260, 13 and 320, 21 and 420, 31 and 560. 31 and 560. Yeah, it's not. 28 and 560 again. 20 and 440. And 25 and 500. Not 5,000. So your numbers should match up. If you don't, you may have missed a number. Give you a second to finish putting those in. Once you have all of your numbers in the next available line, you're going to type this in. It's going to be like our y equals mx plus b, but a little different. Because our table has x1, y1, we need y1, so just type y and then 1. It will do this for you. Then you need this squiggly line, which is called a tilde. It's in your keyboard right here. Then the rest of your, what would be your slope-intercept form? mx1 plus b. So this will give you your m and your b. You would write those together to find your line of best fit. The other things, the residuals, don't worry about that. The r squared is your correlation coefficient that tells you, is this strong or is this weak? The closer this is to 1, that's strong. Or -1, that's strong. But if it was like 0.5, it's weak. You may not be able to see anything on your graph, but if you hit this plus, your point should pop up as well as the line. So this is the line that best fits this data. Do we have questions on how Desmos works? We haven't did any of the prediction part yet, but I'll show you how that works. If any point you change this or maybe it gets really skinny, you can press home. That'll take you back to the main screen, or you can hit the plus again, and that'll take you back to your graph. Okay, let's try one of these examples on the next page, number 1. You can choose whether you want to do this in Desmos or the calculator. I'm going to do another Desmos example. If we want to see another calculator example, I will do that afterwards. Okay. You can either get rid of this and start a new table, or just delete your values and input the next table. For this table, we're talking about hours without sleep and number of hours. Would the number of hours without sleep depend on the number of errors, or would the number of errors depend on hours without sleep? Which of those would depend on the other?
The number of errors is sleep.
Number of errors would depend on hours without sleep. So this one is y, this one is x. So we can go ahead and put those into our table. I'm going to type them on my computer so it'll be faster that way. X2, Y2. So if you made a new table, you have to change this to Y2 and X2. If you kept it the same and just changed the numbers from your original table, you don't have to change this. Keep that in mind. This changes when you put in data. So this would be your new line of best fit. So we can write that for number 1. Y equals 0.354, x plus 4.616. That's over 29. Okay, there we go. 0.475x plus 3. That's what we got. See how putting in a wrong number will change this. So you have to be very careful. What was the number? 0.475. Alright. On Desmos, like most things, it is easier to do the next part. So hours without sleep is 36. So they're telling us our x value or our y value. They're telling us our x. We're looking for our y. So we're going to put in x equals 36. It's going to give you a vertical line that's going to intersect your line of best fit, and that would be your answer. That's it. The work you would say is x equals 36 put into Desmos. That's it.
So what do we write?
20.1. Same thing for the next 2 questions. So change 36 to 54. You may have to zoom out a little bit. What would the y value be there? Click on it. Find where they intersect. Or you can take, I said 2. Find 120. Changing x equals 120. Find where they intersect. I am going to show you what would happen if you were looking for a y value. So let's say we had someone pick a number.
20.
Sure, I heard 14 first. Now 14 is in our table, so it's probably going to, let's do something higher than what's in the table. So how you said 20? 20 is fine. Let's say it said the number of errors. Let's say the number of errors was 20, and we were trying to look for the number of hours without sleep. I'm going to write that so you don't forget. So then you would put in a y equals 20, same thing. See where they intersect. There's going to be a horizontal line, but that would be at about 35.79 hours. and that would be your answer. And again, you would say y equals 20, put into desmos for your answer. Questions on how desmos works? Easier than the calculator, right? You still have the choice if you would like to still practice with a calculator. Moving on to geometry, they won't use this stuff, but in Algebra 2, they will be using strictly the calculator, not desmos, so it is good that you do know the calculator as well. We're going to do one more example, then you'll have time to practice as many of these as possible. We're going to do number 3. Do we want to do this in desmos or the calculator? Okay. If you want to see one in the calculator specifically, I will come to you while you're practicing. Right? Similar, but anytime you see years, you have to change the values. So no matter what the first year is, it will always be 0. Every year after that is how many years has it been since the original? So 1920 to 1925, how many years was that? 5. The next year is still from the original, so 1920 to 1930, 10. 1920 to 1935. Now most of the time, sometimes, if you start to see a pattern, it will follow all the way through. But sometimes that's not the case, so be careful, because they may throw in like a 1957 just because, and then your pattern is thrown off, and then your numbers are thrown off. But these are all zeros and 5, so I can say 20, 25, and keep going. So instead of putting in the years, we're going to put in those numbers, 0, 5, and so on and so forth. Would the year of birth depend on the male life expectancy in years, or would the male life expectancy in years depend on the year of birth? This would depend on the year. So X and then Y. Put those into your table. Be careful. There's a lot of repeating numbers and decimals. Make sure you have all of them.
We do a year like the 0, 5. So 0, 5.
If you were to clear this out, so I'm going to show you this really quickly. If you were to clear it out completely and started putting in 0 and then 5, it will see the pattern you're trying to make, and then you can just keep hitting enter. So that's one less thing you have to do, but you have to get rid of everything in order to do that. Once you have your line of best fit, go ahead and write that on the line of best fit question number 3. Then the question at the bottom says life expectancy in 2010. Are we looking for a X value or a Y value there? Y value in 2010. But because we changed our years to 0 through 80, we have to figure out what year or how many years since 1920 would 2010 be.
90.
So then when we put in desmos, it's going to be x equals 90. And find where they intersect. 0.03 is 90. Always make sure you're putting a label. Are there any questions about how to find the line of best fit? Or linear regression? Those words are interchangeable. You do have a Delta math on this that is due on the 15th, so that is next Friday. You can use this time to either do that or work through as many problems as you can from the remaining pages in Desmos in the calculator. If you want to see the calculator again, I can come around and show you that. If you have any questions, let me know. Make sure you're putting in your numbers correctly. If you are working together, everyone should still be trying to put things into Desmos and find the things.